Regression is a subfield of a supervised machine learning task. The main difference between a classification task and a regression task is that the output variable in the regression is numerical or continuous, while that for the classification is categorical or discrete. In regression, sometimes we call input features as independent values and the output as dependent value. Here we can see a very simple example of a regression problem. Imagine we have some tweets and the task is to predict how many likes each tweet will receive from the audiences. The number of likes is a positive numeric value which starts from 0. It is possible to have more than one output or dependent values in a regression task. If that happens, our task will be called a multivariate multiple regression problem, which I will talk about it in the next slide. But for now, let's assume we have just one output or one dependent value. And we are going to design a neural network model to predict how many likes each tweet will receive. As always, the number of input neurons is equal to the number of input features. In the output, if we just have one output or one dependent variable, we will consider only one output neuron. And we use a linear activation function for that output neuron. Basically, when we say we are using a linear activation function, it is equivalent to say that we don't have any activation functions for that neuron, because whatever neuron calculates from its inputs, it will be considered as its output without any modifications to that. If we have two or more targets or dependent variables, then our task is a multivariate regression problem. In this case, we will consider one neuron for each independent variable in our output layer. So the number of output neurons should be equal to the number of the dependent variables, which in our case, we should have 2 neurons in our output layer. And same as before, we choose a linear function for the activation functions of all neurons in our output layer. One important thing here is that if we have just one target variable in our regression model, we don't need to normalize the output variable. But if you have 2 or more targets and their scale is different, like the number of likes is between 0 to 1 million and the number of comments is between 0 to 10,000, then it is so important to normalize them to make their scale the same. Otherwise, if we do not make the scale of our target variables the same, then our model will put most of its effort to learn the number of likes rather than learning to predict the number of comments. But by normalizing our target variables, both target variables will have equal importance to the model. You may be thinking, why not just run separate regressions for each dependent variable? I mean, having one neural network model to predict the number of likes and another neural network model for predicting the number of comments. That's actually a good idea. We can do that and consider a separate neural network model for each target variable. If we use this approach, then there is no need to normalize the target variables anymore.